Everyone, Diborane, welcome you in this video of Diborane B2H6. Now B2H6 is a strong, powerful reducing agent. So point number one, you can write down, and I hope these videos are helping you like anything. Keep referring more and more, okay? Powerful reducing agent it is. Preparation methods. So how do we prepare this thing? Preparation method. So normally I avoid writing shortcuts, so I'll just recorrect it. Yeah, preparation. You should also have the habit of writing full things, avoid shortcuts. So preparation methods, write down. Diborane is prepared by the reaction of boron trifluoride with NaBH4, sodium borohydride. This is one method. Boron trifluoride, if you write balance it, it will be 4BF3, 3NaBH4 giving you 3NaBF4 and 2B2H6. So this is the reaction of boron trifluoride on compound NaBH4, and that gives us formation of diborane B2H. Now B2H6 has been talked about in detail in inorganic chemistry as well, where we talked about things like 3C2A electronic bonds and all those things, right? So uses of this, use or uses. Number one is a reducing agent. So right now, as a reducing agent, what all it can do. So we'll see everything just at one place, and if required, I'll record one more video for the same if it is too lengthy. The first use is you have RCOH with B2H6, we can get RCH2OH. Okay, so it is acid to alcohol reaction. If you're given RCH double bond CHR prime, which is an alkene, and we do the reaction, so we have done this earlier, it will form RCH2 CHR prime whole thrice. Remember, boron. This is called trialkyl borane. Trialkyl borane, and this we used when we talk about B2H6 THF reacting on H2O2 OH minus. So later B2H6 THF reaction is over, then we bring H2O2 OH minus, and we have removed these things. What about in 1 degree, like what do you call alcohol? Can I say it will give you 1 degree alcohol? RCH2OH from 1 degree aldehyde. If it is a ketone, RC double bond OR prime kind of ketone, what it can give? It can give you this kind of alcohol. So please note down, it is a 2 degree alcohol if that is the case. So I hope you understand all these uses so far. Acid to alcohol, then alkene to trialkyl borane, then aldehyde to alcohol, and then ketones also to alcohol. But ketones, it will give you 2 degree alcohol. One more reaction is RC triple bond N. Whenever you get RC triple bond N with B2H6, remember this is not going to give you CH2H, rather it will give you CH2NH2, which is 1 degree amine. And the same thing we have already done in LiLH4 also. If you remember, LAH also gives the similar thing, CH2NH2. Next example could be, let's say we have examples of lactone. What is lactone? So lactones are basically when you have C double bond OO and certain members of carbons are connected. So it can be different sizes of lactone which are given. So what it does, it just break it up and give you formation of CH2OH at this place and CH2OH at this place. So for example, let's say somebody gives you a question where it is a 5-member ring like this or 6-member ring like this. Let's take this example. So what will happen to this? This part will open up as CH2OH. Then this is as it is, and this carbon will get OH. So you can break it like this, and you can form alcohol sulfide B2H6. So it is also a reducing agent, and these reactions can be achieved. What about if we come across something like a reaction where we have carbons like this and epoxy group like this? Okay, so what it does, it can form again alcohol out of it. So it can give you this kind of alcohol out of it. So all these reactions are specific reactions where we are emphasizing on the roles of B2H6 as a reducing agent. So as a reducing agent, it is capable of doing these things. H minus can attack and this O minus can come out. So we have drawn the structure accordingly. I hope you understood this also. Now questions can be asked, what about esters? So RC double bond OR prime is given. So with B2H6, what we can expect? We can expect that this can be broken, become an alcohol, and the other part can be broken, and anyway it is alcohol. If it is RCOCl with B2H6, so RCOCl with B2H6 and RNO2 with B2H6. So now these two special cases, please note down, there will not be any reaction, and then questions can be asked on these kind of areas as well. So I repeat, there will not be any reaction for this particular case. I hope you understood all these reactions. Now the next set of reaction is NaBH4 acting as a nucleophile, okay, whereas the reactions will be happening as a nucleophile. So what is the role of this, how it is acting as a nucleophile, what are things it is doing, and all those discussions we can do. So you can mention this part. NaBH4 acts as a nucleophile, while B2H6, which we are talking about, acts as an electrophile. So we'll see what kind of reaction we can expect of it, which are electrophilic reaction. So we can do one thing. Let's draw BH4 minus first and see what BH4 minus does. So BH4 minus is providing H minus to attack on any C double bond O, so that the bond will break towards this side, and you get eventually connection of O minus, and this H is joining at this place. And later the other portion of BH3 which is left out the system, this is going to give you alcohol, right? Now if the question is about BH3 and you're given, let's say, C double bond O, so this time boron has not any electrons, so what it will do, it will be rather attacked by oxygen. So the attack will be on this. Once attack will be on this, what will it form? It will form C single bond O, then BH, okay, and if I keep this plus charge here, let's say I keep this double bond as it is, okay, and then plus charge here, then definitely I have to keep a minus here. So what you can do is, you can say that the bond is broken towards this thing, okay, and you can draw the corresponding structure. So what will be the final structure coming up? It will be this kind of structure, and on this you have BH2. And where is this H joining? This H is joining from this place. It is going to attack here, and we have the structure in front of us, which is OBH2 kind of structure. So we can talk about these reactions, and please watch part 2 of this video, which will be again very helpful for you. This is part 1. Don't forget to see part 2. Thank you very much.